Hello everyone and welcome back. In the last lesson we did our first AngularFire query and we have retrieved here a list of courses and we have displayed it here on the home component. What we're going to do now is we're going to move this logic into the courses service. We are also going to talk about a very important property of the observable streams returned by AngularFire. We already have here a skeleton for the courses service, so let's do this refactoring. We are going to take here the private DB variable, which is the AngularFire store service, and we're going to apply it here in the constructor of the courses service. So the idea is that the view layer, in this case the component, does not use this service directly. Instead, this view layer is going to use the courses service. So let's go ahead and inject it here directly in the constructor. In order to retrieve data from the database, we are going to be calling the courses service. In this case, the courses observable is going to be obtained by calling a method on the courses service. The method will look something like this. We are going to call it, for example, load all courses. And this method is going to be implemented with this code here that we had previously at the level of the home component. Let's then implement here our load all courses method. We are going to implement it by pasting the code that we got from the home component. Let's return this observable here. Let's import the mapping operator, and with this in place we are returning here a value which is of type observable of course array. So this means that our home component is now compiled correctly. We are now loading the courses from the database via this service method. Let's try out this new version of the code, and after refreshing our application we can see that everything is still working correctly. So now the data is coming from the database through this load all courses method. Now, before continuing to refactor this method and ordering the courses based on their sequential number, let's have a look at one important property of this stream that we are receiving here, the snapshot changes stream, and consequently the derived stream that we are getting here via pipe. So if we switch here to another window, where on the left hand side we have here our Firestore console, and on the right hand side we have our application, notice the following. If we scroll here through the multiple courses of our list until we find the first card that you see here on the screen, take a look at this. If we edit something here directly on the database, let's add here, let's for example change the title here of this course. We are simply going to call it TypeScript course, for example. If we now click on update, pay close attention here to the title on the screen. We are going to click on update. This is updated on the database, and notice that this was also updated in real time in our application. Let's update the title once more. We are going to add here another word to the title. We click on update and the new title gets again reflected. So this means that the stream that we have here, derived here via the call to load all courses, is a live stream. This observable here that is getting returned here to our home component has not completed after emitting its first value. The observable is still live and it can emit new values over time as our database gets modified. This is very different than a typical HTTP observable, where what usually happens is that the HTTP observable is going to emit only one value, or it's going to error out, and after emitting its only value, then it's going to immediately complete. This observable here does not complete. This also means that there is a live connection to the database. This is done via a WebSocket. This property of the streams returned by AngularFire is very useful in certain situations. So imagine, for example, a stock market application where you are continuously seeing new values on the screen. So for that, these streams are ideal. But on the case of a typical web application such as this one, it might be confusing to the user to all of a sudden see some data changed on the screen without end user interaction. So this would go against the typical UI behavior that the user expects. In order to get back the typical behavior of, for example, an HTTP observable that emits its first value and then it immediately completes, we are going to need a new operator. So here we are using the map operator in order to transform our snapshot results into courses. But after this initial transformation, we can apply here a second operator that is going to wait for the first first value to be emitted, and then it's immediately going to complete the observable. We can obtain that behavior by using the first operator. This operator is going to make sure that this observable gets completed, so this means that if the database gets updated, the new values are not going to be immediately reflected in the view. Let's try this out. We are going to reload the application and we're going to switch again to a larger window. With the new application already reloaded, let's edit here the title again. We are going to remove the first word from the title and we're going to click update. So this time around, we can see that the UI was not updated with the latest value on the database. This is much more in line with what the user will expect in a normal web application. The new value is only going to be reflected on the screen the next time that the user reloads the application. So to summarize, let's remember while we are building our service layer that the streams returned by AngularFire are live by default. This means that we will have a live connection to the database and we will receive the new values continuously over time. This live connection is implemented by the Firebase SDK using a WebSocket, and AngularFire internally uses the Firebase SDK. So this is how the default behavior of the AngularFire streams is implemented. If we want to avoid that default behavior, we need to use the first operator. This is going to wait for the first value to get emitted and then the observable is going to get completed. If by some reason we would like to receive, let's say, only the first 5 values and then complete the observable, we could use instead the take operator. So in this case, we would wait for 5 values to get emitted and then the 6th value would no longer be reflected on the user interface. The most typical case, however, is to simply use the first operator to reproduce the normal behavior that we get from, for example, HTTP observables. In the case of the query that we just built, we are returning here the complete collection. Let's now see how can we filter down the collection by using some of the querying capabilities of Firestore.